Okay, hi guys. I'm talking about Fedora Asahi, which is Fedora for Apple Silicon. It's funny, I was in the bar the other night talking with Davide and Neil about doing this presentation. And I said, yeah, on that Mac Mini, on about 1 in 10 displays, it just doesn't work. So there is a small chance that I arrive on the day and HDMI output won't work. So yeah, we hit that issue. So I was hoping to do the whole demo directly on my Mac Mini, but we had to go to Plan B on my Chromebook here. But I'll still go through it, and we'll still do all the Q&A. I was hoping to show you a couple of things live. But yeah, we'll have to shelve that. I'm Eric Curtin. I work for Red Hat. I work in the automotive org. So that's what I kind of work on. I had a competition, but I have to shelve that because it required the hardware. We'll see. If we have time at the end, I might try and plug in the HDMI one more time. So why do we care about Fedora on Apple Silicon? So Apple released new ARM-based Apple Silicon devices, I think it was late 2020. And there's actually a shortage of well-upstreamed ARM devices. And what's cool about this one is the firmware is unlocked out of the box. So it's actually a feature of the Mac devices to run alternative operating systems. And virtualization is also unlocked on the firmware as well. That's actually a feature I find quite handy. I run VMs a lot on this Mac Mini. And it's blazingly fast. And I suppose Apple would be known for marketing their hardware as premium, and which it is, but it's also great value, great bang for buck in terms of performance. So why do I care? Why did I get involved? Repeating what I said earlier, I work in the Red Hat automotive org. Many automotive boards are ARM-based, so I end up doing quite a bit of work that requires some kind of an ARM environment, and working on the Mac Mini allows me to iterate quickly. And then as a bonus, I learned more about ARM hardware and software implementations and things like kernel space rust and that kind of thing. So these were benchmarks. I did these well over a year ago. I was working a bit, I know it might be quite small and difficult to see. I was working with libcamera at the time, and I just used it as a program to profile different pieces of hardware I had around the house. So it's basically minutes it takes to build libcamera, or seconds even. So the bar on the very left is the Raspberry Pi 4. The green one is interesting. That was my phone. It was like a mid-range Motorola. I had like a Fedora P-Root, it's called, the piece of software. So I had like a Fedora container running on my phone. So that's the green one. The yellow one is also a Fedora container running on my phone, but yellow is when my phone is rooted, so I can get an extra little bit of performance out of that. That was using Chroot rather than P-Root. And the yellow is my company-issued laptop, which is like an Intel i7. And the small blue bar at the end is how long it was taking me to build libcamera on my Mac Mini. And funnily enough, the orange bar, my company-issued laptop, is twice the cost of the Mac Mini. So that's kind of going back to there's great bang for buck with the Apple devices. So what makes the project great? We've really great upstream folk, and we collaborate with these quite frequently. So we've Hector, Alyssa, Asahi Lena, Dougal, Sven, Mark, and there's many more as well. So we've great downstream folk as well. Neil and Davide are actually here. They're big in the whole Fedora ecosystem. They're big contributors. And Michel, Leaf Liddy is another guy. Helps out quite a bit, and there's many more. So this is another thing that I really love about the Asahi community in general. They have this kind of upstream everything attitude. So like absolutely everything we send to the various upstream projects, if at all possible. And that's one thing, there's various certifications around ARM devices. Like I listed just 3 there I could find. One works with Chromebook, and one is Red Hat Enterprise Linux certification, and the third is system ready. But one thing that's in the spirit of all those certifications is upstream everything, and yeah, that's one of the kind of core values we have, and that's actually not as common as you would think with ARM devices. It's almost an exception when absolutely everything gets upstreamed. So yeah, in Fedora Asahi, this is our preferred workflow. So most of the time, things will hit upstream first, and then Fedora will package that up, and then the Fedora Asahi remix will use those packages. So that's the common case. We also use this workflow because sometimes submitting things upstream, it can take a bit of time. So that's a lot of our work as well in the Fedora Asahi community. So sometimes work will be submitted upstream, but it might not be accepted yet. So in Fedora Asahi, we'll take those patches and we'll fork whatever packages we need to make sure you have the best experience possible while things are still being upstreamed. And eventually that will make its way to Fedora when it gets upstreamed, and yeah. I'm going to explain that further in the next few slides. So yeah, obsolescence is a success when it comes to Fedora Asahi. So ultimately, we plan on getting as much as possible into the main Fedora repository. So every time a forked package is obsoleted, I would regard that as a success. So what do we fork? We fork U-boot. That's kind of one I'm kind of expecting could be forked almost forever because we have some Apple Silicon specific stuff in there. Sorry, yeah. I knocked off my mic. 2 seconds. Okay, so we have U-boot. We have a package we call kernel, which is our own kernel. It's separate to the normal Fedora kernel. We have another kernel we call kernel edge. We fork Mesa. We have this kind of firmware package that Hector and them made called M1N1, and there's a handful of others.
What were the reasons U-boot is being forked?
I think we have some flags, build time flags, and we don't have a way of changing how it behaves at runtime yet. I could be wrong, it may not remain forked. The other thing about Fedora as well, we generally try and avoid maintaining firmware and focus on the operating system side. So if you notice our Fedora ARM images, they generally don't get packaged with firmware. We try and avoid getting into maintaining firmware because it can scale quite badly at the lower level pieces of software. So the Fedora kernel, it has Apple Silicon support. It boots. We continually test and enable more kernel configs as support gets propagated upstream. It's built with 4K page size. So that's something interesting in Fedora. In Fedora, we try and just build one kernel per CPU architecture. So at least the way things currently are, we don't build a kernel for 4K, for 16K, 64K, because again, scale. It's easier to maintain one kernel per CPU architecture. So something interesting about this kernel is not everything at the moment is upstreamed with support for 4K page size. That's something that's continually in progress and the upstream folks are working on, but the hardware is designed to work with 16K page size, so we'll get there. Getting everything working with 16K page size upstream is definitely the priority first. The other thing about 4K page size is you take a performance hit because the hardware is kind of tuned for 16K page size. So that's something to bear in mind. The Fedora Asahi SIG then maintains two kernels, and this is the first one. I called it the Fedora Asahi kernel here. So it uses the Fedora kernel as a base, and we then add extra yet to be upstreamed patches from the Asahi Linux repos. We enable even more kernel configs. We build with 16K page size, and it uses simple DRM, which is software rendered graphics, and that's actually surprisingly fast. I'm always amazed at how fast simple DRM is on hardware like this. So if you're interested in Fedora Asahi from a user perspective, I would be recommending this kernel or the next kernel I'm going to talk about, because just the user experience is a bit better, more things work basically. So this is another kernel we maintain. We created this one not so long ago, just before Christmas. So this uses the Fedora, the last kernel I talked about basically, as a base. And we add even more patches and we enable even more kernel configs. So it uses accelerated graphics. What I had intended to do for this talk is that we would have a little competition of two people playing Super Tux Kart, just to show off the accelerated graphics. But HDMI issues. So I found this kernel interesting to work with because it's built with the Rust for Linux kernel space port. And yet the Asahi GPU driver is one of the first fully fledged Rust for Linux drivers, and it's pretty neat. It works well. And another difference is we build this kernel with Clang LLVM because that's basically GCC Rust support is a little bit behind. So at a minimum, you have to build a Rust code with Clang LLVM. And I remember playing around with that package at the time, and at that point, it was just easy to build the whole code base with Clang LLVM, including all the C code. But I think it is possible if you kind of want the hybrid build to build the C code with GCC and the Rust code with Clang LLVM. But we switched everything to Clang LLVM, at least temporarily, because it's easier. And we also use a forked Mesa package, so that works with the Rust GPU driver. So what's our official release date? Davide he's here somewhere. I was talking to him before the talk. He's presenting this stuff at scale in March, in about a month's time. I hope he has better luck with HDMI output and that kind of thing than me. So yeah, Davide is handling our release, so we think we should have an official release out before that. So most of the people working on this are kind of doing it part-time, except for the upstream folk. They're more or less, some of them it's their full-time job. So we're always welcome and open to having new contributors. So if you're interested, reach out to us on Matrix. Apple, it's actually pretty impressive. They seem to be releasing new hardware pretty frequently. So, and every time they release new hardware, there's new things to do because every piece of hardware has its own nuances. Like this is something we were talking about in the last month or two. I don't actually have an M2 device, so I can't test it personally. But WebKit is basically broken because there's this thing. It's a new feature of ARM. It came in ARM version 8.5, and it's called branch target identification. And basically someone has to write the code in WebKit to say if BTI do this, but nobody has done it yet. Which was interesting. I remember yesterday at an Ampere talk, somebody asked the question, can new ARM versions break user space? And I didn't want to answer because I wasn't speaking, but yes, they can sometimes because this is one of those cases. And that's kind of it. I have a couple of links there to our matrix, our wiki, our project tracker, the upstream, asahilinux.org page, and this Git and Copr. You'll find some of our RPMs in there if you're interested. Yes, so that's kind of it. I'll take Q&A now if anyone has questions and answers. And if we don't, and we have a little bit of time, I might plug in the HDMI cable one more time to see if we get very lucky.
So anybody has questions?
Wait, one here.
Hello. At the beginning, you mentioned that Apple Silicon is well upstreamed an ARM device. What do you mean by being well upstreamed? As in, like, does it have work put back into it?
Could you repeat the question?
In the first slide, you said that Apple Silicon is a well upstreamed ARM device, which is why you work on it. What does that mean exactly?
So that's all thanks to the upstream folk, the Asahi Linux folk. So Hector Martin is the lead of that, and he really believes in upstreaming. So like he tries his best. Sometimes certain pieces of code, yeah, he does get difficulty. That's normal. It spans so many subsystems and so many different projects. So the goal is to upstream absolutely everything. And why I pointed that out, there are like plenty of ARM SoCs that publish their code. So they'll like put a GitHub repo out and they'll publish the code there, but they'll never, often they don't go the final hurdle and get it like into Linus's tree. So like it runs out of the box with Fedora, Debian, Ubuntu, all the various distributions. And that's one of the things I love about the Asahi guys, because they go that extra mile to try and upstream everything. So that's what I meant by that.
Hi. You mentioned that U-boot thing that might not be upstreamed. Would it make sense to have a separate project to create an UEFI layer on top of that, to harmonize Fedora in that way?
Yeah. I'll be honest, I did not work on the U-boot stuff myself. I've heard, I think Hector did most of that. He calls it EFI-like, and not exactly EFI. So that might be the reason why it might remain a fork. To be honest, I work more with the downstream folks, so you'd probably have to talk to the upstream Asahi guys about that. I think it was Hector working on the U-boot stuff, but I could be wrong. So yeah. I'll try and plug in the HDMI.
Hi, thanks for the talk. I would like to know how it is to use a new programming language, which is Rust, in the kernel and in Mesa. Is it going to be supported upstream?
I think it's amazing. I'm not going to lie to you and say I've written thousands and thousands of lines of Rust, because I haven't. But building it is easy as long as you use Clang LLVM at the moment. And I believe GCC started they released Rust support recently, so I expect GCC to get there as well eventually. So building it isn't too bad now. Using it, it works solidly. I've never had any crashes or anything. Hector and all those upstream guys swear by it. They reckon like they got that GPU driver written twice as quickly just by using Rust, and you know, by not having to handle memory management manually always and all these things, and it handled thread races and stuff. I think another reason they chose Rust is, I think when reverse engineering the Apple GPU driver, I think it was written in C++. So I think it made it a little bit easier for them because Rust has some of the features of C++. But they swear by it, and they're the guys that actually write the Rust kernel patches, not me.
Do you see a need or a demand for or use for Apple Silicon to run Linux servers in real scenarios in companies and this kind of stuff?
Like in enterprise?
Yes.
Enterprise is tricky because we're very much a community-supported effort, and we don't have any. Apple don't really have an issue with us doing this, but we also don't have an official relationship with Apple. So, you know, it would be hard to deploy Linux on Apple Silicon in a data center when you don't have support, official support from the hardware manufacturer. So, at the moment, I don't see that happening. Unless Apple all of a sudden are like, yeah, we'll support that configuration like in an enterprise environment. Yeah, could happen. Where did the HDMI cable go? Okay. I'm just going to plug it in there to see. Nah. Sorry, guys.
Hi. Sorry, I was just going to wonder, you mentioned that for U-boot you weren't going to push things upstream from your fork. Is that a licensing issue? Like, is it a GPL conflict or something like that, or what's the problem?
Could you repeat the question a little bit louder?
I think earlier you said that for U-boot you would be maintaining a fork.
Yeah.
Is that a licensing issue? Like, is there something you can't commit back to U-boot that they wouldn't accept?
Yeah, I didn't write the U-boot patches. I'm pretty sure that was Hector. I think it's because it's written in a non-standard way. Like, he often calls it UEFI-like, and I think there's certain hacks he had to do to get it working on Apple Silicon that the maintainers may not accept. But I'll repeat, the upstream Asahi community, they really care about upstreaming into the real projects, be it Linux kernel, Mesa, etc. So if all possible, I'm sure they will, you know. Sometimes there's just hacks required because it's built to run Mac OS at the end of the day. So.
Some questions?
I'll be around for the day. If any of you see a monitor around the campus or whatever, and you want to see it in action, we can hook it up and try. I'm open to that. So yeah, it's about, I've seen this happen before. 90% of monitors work, so if you find a random monitor, yeah, we can do it. Okay.
Okay, so thank you, Eric.
Thanks, guys. Thanks very much.